Hi, this is Stephen Brower from Raritan Valley Community College. This is meant to be one of the addendums for Chapter 1 out of Stallings. And what this is intended to go over is the IAS computer that is covered in Chapter 1. This is the one that was designed by John von Neumann. Now, it follows what's known as the stored program concept, in which the instructions reside in memory along with the data. And so what this is supposed to be a logical sort of representation of this is the memory represented in binary, and a portion of the memory has the instructions, and a portion of memory has the data. Each instruction has two pieces to it. The first piece being the opcode, the second piece being the address it's acting on. Within the CPU itself, one of the things logically that's in there is the program counter that is pointing to the next instruction to be carried out by the computer. So on a fetch, it looks at the program counter to figure out what is the address, and what this slide is not going to show is how it is going to go through the MAR, the memory address register, for getting to that memory in terms of it. In terms of where that instruction is. I just want to show the logical effect, which is on the fetch, the instruction that's being pointed to is brought onto the CPU. So if I do the animation right, the opcode is brought into the instruction register, then the address is brought to the instruction buffer register. And so let's say on the fetch, let's say that this here is meant to load into the accumulator the value that is at this address. So suppose this address is logically pointing here, and then on the retrieving of the data, it will be temporarily stored into the memory buffer register. So this would be a copy of the data as it is brought in. And then if it's supposed to then load that into the accumulator, then the accumulator would be loaded with the data that came from memory. The opcodes that I have here, I just randomly picked some ones and zeros. And the same thing with the addresses. I just randomly picked some ones and zeros. In Chapter 3, we will relook at this. We'll look at a hypothetical machine. We'll have a specific instruction set, which is a specific set of operation codes, opcodes, that we will be dealing with. And we'll trace through kind of what I just did. We'll trace through how that looks going through the computer, through the processor itself. So within Stallings Chapter 1, one of the things that's done is that the logical components of the CPU are shown. Now it shows them physically because the initial computer, it wasn't one chip, it was more than one chip. And they logically grouped these things differently based on what was on one chip and what was on the other. I just kind of drew one area as logically this is all part of the CPU. The slides have the definitions for all of these things. So the program counter, the instruction register, instruction buffer register, memory address register, memory buffer register, and the accumulator. And so this is just that one aspect that is in Stallings Chapter 1, the stored program concept, and a high-level overview of how the IAS computer works.